Welcome Math 107 students to the demo for lesson number 3, where we're introducing you to some features of graphs, and we're also introducing you to some graphing utilities, one being the TI-83 or 84 graphing calculator, and the other graphing utility called GeoGebra, which is a free software program that you're able to download. And you'll have some practice with GeoGebra in your very first project. So let's take a look at finding the x and y intercepts of a graph. The x-intercepts of a graph are the places where the graph crosses or intercepts the x-axis. Similarly, the y-intercepts of a graph are the places where the graph crosses or intercepts the y-axis. So let's write the coordinates for the x and y intercepts from our equation that we looked at in our preview activity, which was the equation y equals 4 minus x squared. So here's a graph of the equation y equals 4 minus x squared. And if we want the coordinates of the x-intercepts, all we have to do is find the places on our graph where it crosses the x-axis. So we see that it crosses at -2, 0 and +2, 0. So those are our x-intercepts, -2, 0 and 2, 0. Okay, and then similarly for our y-intercept, we're looking for the spot on our y-axis where the graph crosses the y-axis, and that occurs right here at 0, 4. 0, 4. So when we have the graph of an equation, we can simply look for the places on the graph where the graph either crosses the x-axis or the y-axis. In this case, these places were nice integer values, and we could clearly read the ordered pairs directly from the graph. But sometimes it's not clear from the graph what these coordinates are, and we have to estimate, but we can use algebra to always find the values for these x and y intercepts. So even though we know what these values are, let's see how we would use algebra to find the x and y intercepts. So all you have to remember is what makes an x-intercept special. Well, what makes an x-intercept special is that y is equal to 0 for all x-intercepts. So when you are asked to take this equation, y equals 4 minus x squared, and find the x-intercepts, what you do is you replace y with its value, which is 0. When you have an x-intercept, y is 0, and then you solve the remaining equation. So we have 0 equals 4 minus x squared, and this is a quadratic equation, which we're going to be looking at all of the details of solving this in just a few short lessons. But I think we can sort of look at this equation and think about how we would solve it. We would add x squared to each side, and we would have x squared equals 4. And for now, we're going to skip the algebraic process that we would use to get down to the values for x, because we can look at this, and we'll just go ahead with what we know now from looking at the graph, and also that this is a simple equation to solve, that if I put a 2 in here, 2 squared is 4, or if I put a -2 in there, -2 squared is 4. So until we get to the quadratic equation section, which is coming up shortly, we'll just use this information from our graph to solve for these x-intercepts. Now, these are the solutions. So I didn't quite finish my question here. It says find the x-intercepts. So remember, these are the x values, and then the y value is the partner for x. So we have -2, 0, and 2, 0. So those are the x-intercepts. So how do we find a y-intercept algebraically? Well, whenever you cross your y-axis, what makes that special is that x equals 0. So you go back to your original equation that has x and y in it, and you let your x value be 0, in this case 0 squared, and you get y equals 4. So your y-intercept in this case, and again we can see it from the graph, is 4, 0. this is the algebraic process you go through to find the x and y intercepts for the graph of an equation with two variables. Okay, what if we wanted to do that with our graph, one of our graphing utilities, in particular with our TI graphing calculator? Well, the first thing you're going to do is you're going to put in the equation into your calculator. And the way you do that is first you turn on your calculator, which we've done. Oops. And then you put in to where it says Y1. You could choose Y1 or Y2, it doesn't matter. We just differentiate all our Y's with these little subscripts, 1, 2, 3. So this is going to be our first equation we're going to graph. And you type it in. Let's start right from the beginning so you can see how I do this. So I type in 4, take away, and then my x is located right here with this button here. It's x. And then to square, you can either press this button that says square, or you could use ℏ2. Since we have the square button right here, let's just put a little square on it. Okay. So now we have entered our equation. And the other thing that we need to tell the calculator is what are going to be the values along my x and y axis for graphing this equation. And that's the word, we refer to that as the window button on our graphing calculator. And let's put this over here. The window button is located right here, right beside where you put the equation in. Now, the window button has sort of a default, and that default is called the standard window. And the standard window has these properties. Notice I have this series of little brackets here with 3 numbers in it by times another bracket with 3 numbers in it. And what each of those number represents can be seen right here. This is a new notation for some of you. So I'm going to just call up the window so you can see it simultaneously. So the very first number you see here, the -10, is the x minimum value, and you can see it up here, the x minimum. So what that means is on this particular picture, which I graphed with a standard window, the smallest number you see on the x-axis is -10. The largest number, x maximum, is 10. You can read it from this calculator or you can read it from this notation. And that means this last little tick mark there is 10. And the scale I'm going to use to move from one number on my number line to the next is a scale of 1. So you would know the next number would be -9, -8, 0, 1, 2, 8, 9, 10. Okay. Then this by now tells you that that's the scale used on your x-axis. And now we're going to look at the scale for our y-axis. Again, the very first number you see after the bracket is the smallest value for y, which is in this case -10. The next number is +10. That's the largest value. And then the scale we use along our y-axis as we move from one value and along our axis to the other is a change of 1. So you can either go in and change the window, but if it's a window that's used often like this one, the standard window, there's a shortcut, and that shortcut, so let's say here I put in my equation and I want my standard window, I just go zoom 6. Notice zoom 6 is the standard window. I do zoom 6, and there is the graph that you see on the right hand side of this page. Okay. So, you know, you can go in and you can change this window to be anything you want. You could say -20 to 20, and I want it to increment by 2. And then you could hit the graph, and now you get a little different picture than what you see on the right-hand side here, because this value out here is -20, and the next value is -8. It's like zooming out, like you're getting further and further away from the graph. So that's why it looks a little more narrow than this one here. So really, sometimes with graphing equations on the graphing calculator, the hardest part or the part that takes a little more time sometimes to figure out is what window can I use so that I can see the essential features of my graph, its shape and its x-intercepts, the y-intercept. Sometimes it takes a little more work than the standard window, but again, the standard window comes in handy in quite a few situations. The other situation we're going to look at is how would we make a graph from this software program called GeoGebra. Well, it's actually a very simple piece of software to use. You can see I've made the graph y equals 4 minus x squared, which is the same as negative x squared plus 4. And all you do when you want to graph something like this, I'm just going to turn it off for a minute so there's no graph, is you go down to the bottom where it says input and you write y equals 4 minus x comma square, x caret square. And what you see here is the graph. And if you wanted to move this graph around, you use this four-way arrow. It's very useful. Notice that this graph has a little letter D here. D stands for the object name. We're saying that this is an object. If I put a straight line in here, it would be another object. And D is the object name. But often when you pass in something like a project or you're graphing something for us to look at or for you to put in your homework, you don't want to see the object name here. You want to actually see the equation. So there's a really neat way you can get the equation. If you go anywhere on your graph and you right click, this is a very important property to use. You see object properties. So when you click on object properties, this is where you could change the color of the graph. For example, let's suppose I want it to be this purplish color. Okay, so now it's purple. Notice the name of the graph is D. Its definition is the equation. Now, the label, right, it's showing this object, which is the parabola, and the only label that's on here is the name of the parabola. And usually I don't care about the name. I want the value, which is the equation itself. And there you see the equation. There it is, y equals x squared plus 4. Okay, if for some reason you wanted your style of your line to be thicker, you can just move this arrow so it's thicker. You could also change it so that it's dotted. Okay, so if you were graphing more than one thing, more than one equation, you could have, say, a dotted line for the parabola and a solid line for the, say, a straight line. So you'll get used to working with this as you work through your projects, but as you can see, it's just a few clicks here and there, and you can come up with a very nice looking graph. So that's it for the demonstration for lesson number 3. If you have any questions, please let me know.